Okay, don't bump it. All right, here we go. We're going to do a practice.
Good morning.
Let's see what you can remember. You will use a calculator for this. Obviously, we're doing trigonometry, so we need a calculator. This is our practice quiz. Because tomorrow we are having the real thing. And the next day, we'll have the real thing. Whenever I see you again.
I love it when you call me.
All right, here we go. Everybody. Okay. Number one. Two-part question. We are finding X and Y and Z. Oh boy. Let's see what's going on here. X, Y, and Z. All right, let's see if we can figure this out. So, tell me about Y. Let's start there.
That's the adjacent.
That's your adjacent side. Well, for this angle, it would be the adjacent side. But I have two sides of a right triangle. How can I always find the third side?
Can you square it?
The Pythagorean theorem. So what's the Pythagorean theorem going to look like for this triangle? 5 squared plus y squared equals 8 squared. Very good, Emmett. And notice, Emmett put the 8 over here by itself because that is the hypotenuse, and the hypotenuse goes over there by itself. So we can do this arithmetic either with or without our calculator, whatever flips your switch. So I'm getting 39. So when I square root that, I just get the square root of 39. Now, 39 is indeed 3 times 13. But it doesn't break down. Don't write 3 root 13 or something like that, because you only have 1 3 and 1 13, right? And in order to simplify, you got to have 2 of them. So the answer for y is just root 39. That's y. Now, what about these angles? We know they all add up to 180, and we know that one is 90, but we got to find one of them. One of them we have to find, and it doesn't matter which one. So, Toby, you want to find X or Z? Makes no difference. Just pick one. Z. Toby wants to find Z. All right? Now, what you have to decide is, when you look at Z, you have to decide which function you're going to use, because in order to find that angle, you're going to use sine, cosine, or tangent. Okay? So if we're going to do Z, this side over here is the opposite. This side is the
Hypotenuse.
That's the hypotenuse, right? So if I use 5 and 8, I'm using opposite and hypotenuse. Now, could I use root 39? Yeah, but yeah, use it if you want. I'm going to use the whole number, so I'm going to use 5 and 8. And if I use 5 and 8, then what function is that going to be? That's not tangent. Sine. Why is it sine? Opposite and hypotenuse. Write SOHCAHTOA at the top of your page if you need to, if that helps you. Because as soon as you see so, assuming you spell it right, you've got opposite and hypotenuse right there. So, sine angle, and the angle he picked was Z. sine angle equals opposite over hypotenuse. And how do I find z then? What am I going to have to do? Second sine. So I'm going to second sine 5/8. Make sure your calculator's in degree mode, which it should be because we won't be switching back and forth in this unit. So once you set it in degrees, unless you loan it to somebody, you should be all good. So second sine 5/8. Did you get 38.68? So z is 38.68. Could I do the same thing for x? Yes, but you don't need to, right? Because what do we know about all the angles of the triangle? They add up to 180. So we have a 90, we have a 38.68, and that's going to leave 51.32 for angle x. Now, again, Toby randomly picked z. Could he have started out by finding x? It makes no difference. But whichever one you do, you're going to be using SOHCAHTOA. So you're going to use SOHCAHTOA to find one angle of the triangle, and then you can just subtract from 180 to find the other one. Okay? And how do we find a side? Pythagorean theorem. Right? Okay. One more question. Find the area. Anybody remember what I told you about area yesterday? Well, it's 1/2 base times height. Actually, you told me that. You remembered that. Very good. 1/2 base times height. What did I tell you about the base and the height? They're the two that make the right angle. So I know some of you are looking at that triangle and thinking, oh, I don't know the base. Yes, you do. Here are the base and the height of the triangle. They're the ones that make the right angle. So the area of that triangle is 1/2, 4 times 7. So that will be 14. And on your quiz, I'm going to put a unit here. So let's say I put feet. Then your area will be feet square, right? You got to get in the habit of square units for area. Okay, that's our quiz. If you feel like that's going to be an issue for you, then maybe I'll see you during flex and we can practice a little bit. That's your quiz next time I see you. All right, everybody good with that? No questions? Then let's get our notes out and let's talk about the law of sine. Alright, so we had gotten...
We didn't finish.
Oh no, because we hadn't practiced the law of sine yet. But we did find angle H. What did we figure out angle H was going to be? 62?
52.
And that was easy because we had two angles already. So we just subtracted from 180 and got that one. So that was easy. Now we have to find side C, which is located across from angle C, and side S, which is located across from angle S. And we love SOHCAHTOA. We're going to use it on our quiz because our quiz is going to have a right triangle. Pythagorean theorem, SOHCAHTOA, all that stuff. None of that works in this triangle because this triangle does not have a right angle. Okay, did everybody hear me say that? Because Pythagorean theorem and SOHCAHTOA are awesome, but you can't use them unless you have a 90-degree angle. So instead, we said we were going to use our law of sines. And it is really easy to memorize. Everything's just paired up. This is the sine of the angle over the side, the sine of the angle over the side, okay? So when I look at my situation, right here, I have what we call a pair. We have an angle and its side. 52 goes with 11. So I'm going to start out by saying sine 52 over 11. Now, as crazy as this seems, I'll have kids say sine 11. No, 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 no. If you're signing something, it has to be an angle, right? So sine 52 over 11. I'll have people put just 52 over 11. No, no, no. It's called the law of sines. You got to have the sign in there. So it's sine 52 over 11. And what am I going to set that equal to? Pick one. Yeah, it doesn't matter. Pick one. How about sine 58 over C? Could I have said sine 70 over S? Yep, and that's going to be my next step. It's just like when Toby picked an angle. Just pick one. Pick one. So sine 58 over C. Now, does that make sense to everybody? That's the law of sines. How are we going to solve that? Not going to my calculator yet. How am I going to solve it? Cross multiply. Very good. So cross multiply, that'll say C sine 52 equals 11 sine 58. Everybody see cross multiply? We're trying to figure out what C equals. That's our goal here. So we're going to divide by sine 70 or sine 52. So 11 sine 58 divided by sine 52. Now, you're so sick of hearing me say this, but guess what's going to happen when I type this into my calculator? When I hit, watch, go ahead, do it, 11 sine, the minute you hit sine, it's going to put in a parentheses, you're going to type 58. What are you going to have to remember to do? Close the parentheses before you hit divided by sine 52. So it's just like with the logarithms, exactly the same thing. You're going to type it all in, but you got to remember to close the parentheses before you hit divided by. And I got, for side C, I got 11.84. Is that what you got?
There's game third.
Okay, yeah, I didn't do that.
Now, one thing to make sure is your calculator's got to be in degrees, obviously. Okay, now, what about side S? Exactly. Don't use the Pythagorean theorem. I'll have kids try to use the Pythagorean theorem. But you can't because it's not a right triangle. So we're going to start all over again. So now we'll say sine 52 over 11. And I would use that same pair because that's got no round-off error. That was given information. Only this time I'll set it equal to sine, what? 70 over S. So sine 52 over 11 equals sine 70 over S. We'll do the same cross multiply. S sine 52 equals 11 sine 70. And then what? Divide. So S equals 11 sine 70 over sine 52. And we'll type that in. 11 sine 70, close parentheses, divided by sine 52. I got 13.12. Did you? Everybody so far, everybody okay?
Nice shot.
All right, let's look at the next problem.
That's a shot and a half.
It's another triangle. And we are solving it. And remember, solving a triangle means find everything that's missing. So this time what we're missing is angle C, angle H, and this side over here. What do I call this side? Side H. Very good. Why is that little h? Because it's across from angle H. Now, do we see any 90-degree angles in there? No. So we know we're going to need our law of sines. Okay, nothing else at this point. All we have is the law of sines. So here's the pair we're going to start with because that's the pair that we have. In every law of sines problem, you're going to have that pair. We'll talk about what we do if we don't have that pair later. But right now, we're going to start with that pair every time. So, what's that look like? Sine 125 over 15. Now, last time we kind of had a choice. This time we don't really have a choice because the only other thing we know is that, right? So we're going to have to say sine C over 6.5. Would you agree with that? I mean, if you tried to say sine H over H, you'd have too many variables. Okay, tell me what to do now. Cross multiply. So 6.5 sine 125 equals 15 sine C. Now guys, this is a package deal. That's not separatable. So the best you're going to be able to do is to divide both sides by 15. So if I divide both sides by 15, then I have an equation that says sine C equals 6.5 sine 125 over 15. Would everybody agree with that? That's what we have if we divide those sides by 15. Now wait a minute. How do I solve it when the C is after the sign? Second. I have the second sign. So you are simply going to hit second sign and then type in that. So 6.5 sine 125, close parentheses, divided by 15. And if you did it right, you're going to get 20.79. Okay, so let's try that again. If you didn't get it right, type second sign. Anytime the variable is after the function, like log x, sine C, we have to second. So second sine 6.5 sine 125. Make sure you close the parentheses. You won't have to put that one in, but you'll have to put that one in. Divided by 15, and it should give you 20.79. angle H? Could we do the same thing? No. How are we going to find angle H? Add them up and subtract from 180. Don't we have two of the angles now? So that angle H is going to be easy. So 180 minus 125 minus 20.79. I got 34.21. Okay. Now we got to find side H. Who's got a plan for side H? Anybody have a plan? Someone should have a plan. Law signs. We're doing the law signs. So what's it going to look like? Sine 125 over 15.
And then sine H over 34.21.
Yep. So, well, no, not quite, Sam, but close. Sine 125 over 15 equals sine angle, so sine 34.21 over H. Remember, it's always sine angle. The angle always goes with the sine. So sine 125 over 15 equals sine 34.21 over H. The good news is we always solve them the same way. We're going to cross multiply. So H sine 125 equals 15 sine 34.21. Am I going to have to be doing any second signing in this problem? Will I do second sign this time? No. What is the only time I do second sign? When it's sine C or sine H or whatever. If it's sine angle, which it is, sine angle, I'm good. I just type in sine angle. So 15 sine 34.21, close parentheses, divided by sine 125. I got 10.30. While you're catching up there, this is a good time to point something out to you. Some of you on your test, it was really awesome to see. Even when you got the wrong answer, you put a little question mark over here because you knew the answer you got didn't make sense. You knew it was wrong because it didn't make sense. These are kind of the same way. You don't know whether you got exactly right, but you can kind of make sure it makes sense. Here's what I mean. In geometry, you learned that the bigger the angle, the bigger the side would be. So does it make sense that 125 is across from 15, 10 is across from 34, and 20 is across from 6.5? Does that make sense? Yes, because the big side is aligned with the big angle. So after you're done, kind of just stand back and look at your problem, because if you would have typed this in and gotten this to be 37 or something, you would immediately say, whoa, that can't be, because 125 is across from 15, 34 cannot be across from this big giant number. In geometry, the bigger the angle, the bigger the side. Okay, so that was not 37. I forget what it was, but it wasn't 37. All right, ready to try one more before we do a word problem? All right, here we go. Problem 3. Not a right triangle. So we're not going to be using the law of, or we are gonna be using the law of sines, we're not gonna be using SOHCAHTOA. Marcella? What do we need to find in this problem? What are the missing pieces? Angle S, right? And then these two sides, right? What do we call this side? What would this side right here be called? C, little c. And this side right here would be called little h. Perfect. So these are the three pieces we have to find. Now scope it out, Addie, look at it. What might be the easiest thing to find first? Side H? Well, we can find side H, but we need... Totally. At angle S is where you want to start because you've got two angles already. So you know the third one is going to be whatever 180 minus those is. So that is definitely where we want to start. And I got 97. Did you? So those are easy points. The angles of a triangle always add up to 180. So if you know two of them, you can always find the third one. Easy. Now, see this right here? That's going to be like my foundational piece for my proportion, my law of sines. Sine 97, so it's always sine of the angle over the side. And now what do you want to set that equal to? You get to pick. What do you want to set it equal to? Sine 32 over C. Make sure, kids, you got that you must do sine angle. So that sine of 97 over the side, sine of 32 over the side. All right, go ahead, cross multiply, divide, see if you get the right answer. I'll do it too. Make sure you're closing parentheses as necessary. Jackson, you typing it in? Okay, well, let's all type it in. You too, Emmett. Thank you. What'd you get?
4.4 or 6.41.
6.41. That's what I got too. Good job. 6.41.
Touchdown Brown.
Touchdown Brown, whatever that means. Yes, indeed. All right. Now what? We're not done. We still have side H to find. Maddie, what do you think for side H? What might we do? Well, I already did that one. So I'll do sine 97 over 12 equals what? Not 51. Sine 51 over H. So sine 97 over 12 equals sine 51 over H. Remember, it's never the angle by itself. It's sine angle. Sine angle. All right, type that one in. And would everybody please do it? Don't make me yell on screen. Get your calculator out, type it in. Let's all make sure we can get the right answer. just like before, if you use more steps than this, that's fine. If you use less steps than this, that's fine. Just want to end up with the same answer. .40. Everybody okay? All right, just for fun, let's take a break from the notes for a minute. And, well, if there's room on there, you can do this on there. You can write it on the desk. I want to give you a problem and have you work it out, start to finish by yourself or with your partner. And let's see if we can solve a triangle using the law of sines. So let me set one up here. So you see different letters. I use my husband's initials. And let's say angle T is 63 degrees. Angle F is 47 degrees. And side E is 10. Solve that triangle. Is there anyone who feels confident and comfortable coming up and doing it on the board?
Me.
Sam? Awesome.
On the board? Or no, right here?
Either one. But I wanted somebody to do it on the board.
I'll
But
do it.
you're okay? All right. Bring your calculator up. You want to help her or you think you got it? I got it. Load it.
That's what you want to do. Huh? Yeah, get all the way. Sorry. Sam's I can get poisoned.
Everybody should be working on this, guys. Practice makes perfect. Check, make sure it's in degrees.
Wait, is it recording? So that'd be 10 times 63? Okay.
Sam's cranking out some answers here. here. You want to check your work with this. You found side T first. We found this angle first, then found side T. Now he's working on side F. Very nicely done. All right, Sam's done already. I don't know if you guys are done. No, still working. All right, check your work up here with Sam because he's absolutely perfect. His work is perfect. So your goal is to get the same answers he got. Is anybody not getting those? Did you not get those?
No, I didn't.
Angle 70, that should have been your first step, so everybody started here, I hope. Anytime you've got two angles, you want to find that third one, so that just worked out to be 70. Then this became kind of his foundation fraction here, the one he started with, sine 70 over 10 in both of his problems, and then he did the other, whatever he was looking for, sine 63 over t and sine 47 over f. Beautifully done. Nice work. All right, so that means then that we should be ready to look at this word problem and figure out what in the heck's going on with it. Alright, so we got a ship on a bearing of 120 from port A, so I drew that for you, and 42 degrees from port B, got it. A and B are 15.2 miles apart. A and B are 15.2 miles apart. So what does that mean? This right here would be 15.2. Is that all right with everybody? So wait, so Emmett says this angle, obviously we're looking at a triangle here, and Emmett says the angle inside the triangle would be 60. How does he know that? These are called a linear pair, not that you need to remember that, but what do we know about a linear pair? They make 180 degrees, always. A line is 180 degrees. Now, I forgot to say, what am I looking for? Find the distance from the ship to each port. So I need to find this distance right here, and I need to find this distance right here. Now, if I use my, like, real lettering, this distance would be little b, and this distance would be little a. But you can call them X and Y or something different if you want to. Any 90-degree angles in there?
Nope.
No. So this is going to be the law of sines. Angle S. S is what? 78. Everybody catch that? Because these two are known. They're 102. That's got to be 78. Perfect. I see some of you typing already. That is awesome. What did you set up?
Sine 78 over 15.
Yep. Sine 78 over 15.2. equals sine 42 over b, or and, we have to do both of them, sine 78 over 15.2 equals sine 60 over a. Right? Don't we have to do them both? In either order, makes no difference. Let's see what we come up with as answers. If you're willing to volunteer, shout it out if you got one of them or both of them. What'd you get, Will?
B, 10.4 out.
Yep, that's what I got.
Way to go, Will.
And anybody get A yet? Will?
13.46.
Yep. Now, this is a word problem, so I want to make sure that I answer appropriately. Since the 15.2 was miles, this would be miles, and this would be miles. Now is the time you should be asking a question if you're not getting those numbers. You gotta make sure we can get those numbers. Maddie, you getting those numbers? Aiden? Tessa? Chuck?
Yep.
D. A Park Service plans to build a bridge, AC, over a lake. A and B are 2 points on the shore, and AB is 14. If angle A is 102 and angle B is 58, find the length of the bridge. Well, let's see. So here's angle A, B, and C. And of course we got the lake. We don't really care about, we're just looking at the triangle. And let's see, what do we know? We know that A and B, AB is 14. And angle A is 102 and angle B is 58. And we want to find the length of the bridge, which is AC. Is that what you understand from the problem?
Yeah.
Who's got a plan or an idea?
Angle C is 20.
Angle C is 20. That's good. Anytime we know two angles, we're going to find the third one, right?
So sine 20 over 14.
So sine 20 over 14, Sam, you're on fire, equals sine 58 over x. Now, this is the first problem where we haven't wanted to know both sides. So we're going to start with sine 58 over x because that's the one I'm looking for, right? I could do sine 102 over this, but I don't need that, so I'm not going to. I'm going to say sine 58 over x. Perfect. Type it in, see what you get.
No?
$34.71.
34.71. And I think that was meters.
Doesn't it have a?
It doesn't have a unit. But yeah, it does.
AB is
Meters,
14
yeah.
meters. So we'll use 4.71 meters. All good? All right, here we go. Two people at A and B observe a sailboat at S. All right, so let's see if we can figure out what's going on. Here's our picture. Okay, so what's happening is this guy, there's a guy right here, and he's looking out at the sailboat. And there's another guy over here, and he's looking out at the same sailboat. A and B are 20 meters apart. So we'll put 20 here. Angle A, remember, capital letters mean angles. So angle A is 65 and B is 42. And those are degrees. I should have put degree marks on there. Find the distance from S to AB. This is a very tough question. If I said you, let me draw the triangle, another triangle. That triangle looked like this, standing straight up and down, and this was A and D, and this was S. And I said find the distance from S to AB. Wouldn't that be right there? When we talk about distance, we talk about the shortest distance, right? That's the perpendicular. So I gotta drop a perpendicular down here. And how you drop it, where you drop it, don't get all screwed up about that. Just make a right angle in that picture. And that is what you are looking for. Now, the good news is that well, both of these are right triangles. So if I had enough information, I could do SOHCAHTOA or Pythagorean theorem. This is a very tough problem. Anybody have a thought? What'd you say?
The missing angle.
Well, I can find that angle, right? I'm gonna just temporarily, let me pull this back out for a minute. Can I find that angle up there? Yeah, what is it? 73? Okay. Now, I know that I don't need it, but could I find one of the other sides of the triangle? All right, let's just find one. Let's just find this one right here. Let's find side B. So, sine 73 over 20. Bear with me, guys. You're going to see the method to my madness here in a minute. Sine 42 over B. So sine 42 over B, sine 73 over 20. So let's go ahead and type that in and see what we get. What'd you get, Sam?
I got 0.699.
Try it again.
I got
13.99 is what I got. Try that again, Sam. You've been getting them all right. You must have just hit a wrong button.
Yeah, that's not really right.
Okay. Now, you're sitting there thinking, Mrs. Ford, well, why in the world did you do that? Well, let me put my perpendicular back in. And that is what I really want to know the length of, right? Look at this right triangle now. Think about SOHCAHTOA. or think about the law of sines, it doesn't make any difference. We know that this side is the opposite side, and this is the hypotenuse. So could I say sine 65 equals x over 13.99? Would that be a legitimate thing? Sine 65 equals x over 13.99? And then I can solve, and I'll have x. Now, for those of you that are thinking, oh my goodness, I'll give you another option. Let me get this typed in first. I got 12.68. Is that what you got? And I think it was somewhere, I thought there was a unit in there. Yeah, meters. Okay. Now, we're kind of in law of sines mode. So let's look at this right triangle right here. Could I say sine 65 over 12.68 equals sine 90 over 13.99? Look, sines, oh, wait, which one did I not know? I didn't know this, right? So sine 65 over x, before I knew what that was, could I say sine 65 over x equals sine 90 over 13.99? Type that in, solve that, and you're going to get exactly the same answer. So what I'm trying to show you is you no longer need SOHCAHTOA. You can always use the law of sines if you want to. Did you get 12.68? You sure did. The law of sines works in every single triangle ever in the whole wide world.
So you're saying we don't need to use like this sign? You can stick
You don't need to
SOHCAHTOA?
use SOHCAHTOA anymore. No. Now, a lot of people think SOHCAHTOA is easier. It's the first one we learned, so it's more in our head. But you do not need ever to use